Networking and content delivery. Amazon VPC. Amazon Virtual Private Cloud, Amazon VPC, lets you provision a logically isolated section of the AWS Cloud where you can launch AWS resources in a virtual network that you define. You have complete control over your virtual networking environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. You can use both IPv4 and IPv6 in your VPC for secure and easy access to resources and applications. You can easily customize the network configuration for your VPC. For example, you can create a public-facing subnet for your web servers that has access to the internet, and place your backend systems, such as databases or application servers, in a private-facing subnet with no internet access. You can leverage multiple layers of security, including security groups and network access control lists, to help control access to EC2 instances in each subnet. Additionally, you can create a hardware virtual private network, VPN, connection between your corporate data center and your VPC and leverage the AWS Cloud as an extension of your corporate data center. Amazon Cloudfront. Amazon Cloudfront is a fast content delivery network, CDN, service that securely delivers data, videos, applications, and APIs to customers globally with low latency, high transfer speeds, all within a developer-friendly environment. Cloudfront is integrated with AWS- both physical locations that are redirectly connected to the AWS global infrastructure, as well as other AWS services. Cloudfront works seamlessly with services including AWS Shield for DDoS mitigation, Amazon S3, Elastic Load Balancing or Amazon EC2 as origins for your applications, and Lambda at Edge to run custom code closer to customer users and to customize the user experience. You can get started with the content delivery network in minutes, using the same AWS tools that you're already familiar with, APIs, AWS Management Console, AWS CloudFormation, CLIs, and SDKs. Amazon offers a simple, pay-as-you-go pricing model with no upfront fees or required long-term contracts, and support for the CDN is included in your existing AWS support subscription. Amazon Route 53. Amazon Route 53 is a highly available and scalable cloud domain name system, DNS, web service. It is designed to give developers and businesses an extremely reliable and cost-effective way to route end users to internet applications by translating human-readable names, such as www.example.com, into the numeric IP addresses, such as 192.0.2.1, that computers use to connect to each other. Amazon Route 53 is fully compliant with IPv6 as well. Amazon Route 53 effectively connects user requests to infrastructure running in AWS such as EC2 instances, Elastic Load Balancing load balancers, or Amazon S3 buckets, and can also be used to route users to infrastructure outside of AWS. You can use Amazon Route 53 to configure DNS health checks to route traffic to healthy endpoints or to independently monitor the health of your application and its endpoints. Amazon Route 53 traffic flow makes it easy for you to manage traffic globally through a variety of routing types, including latency-based routing, GeoDNS, and weighted round-robin, a LOF which can be combined with DNS failover in order to enable a variety of low-latency, fault-tolerant architectures. Using Amazon Route 53 traffic flow's simple visual editor, you can easily manage how your end users are routed to your application's endpoints, whether in a single AWS region or distributed around the globe. Amazon Route 53 also offers domain name registration. You can purchase and manage domain names such as example.com, and Amazon Route 53 will automatically configure DN settings for your domains. AWS Private Link. AWS Private Link simplifies the security of data shared with cloud-based applications by eliminating the exposure of data to the public internet. AWS Private Link provides private connectivity between AWS services and on-premises applications, securely on the Amazon network. AWS Private Link makes it easy to connect services across different accounts and VPCs to significantly simplify the network architecture. AWS Direct Connect. AWS Direct Connect makes it easy to establish a dedicated network connection from your premises to AWS. Using AWS Direct Connect, you can establish private connectivity between AWS and your data center, office, or colocation environment, which in many cases can reduce your network costs, increase bandwidth throughput, and provide a more consistent network experience than internet-based connections. AWS Direct Connect lets you establish a dedicated network connection between your network and one of the AWS Direct Connect locations. Using industry standard 802.1q virtual LANs, VLANs, this dedicated connection can be partitioned into multiple virtual interfaces. This allows you to use the same connection to access public resources, such as objects stored in Amazon S3 using public IP address space, and private resources such as EC2 instances running within a VPC using private IP address space, while maintaining network separation between the public and private environments. Virtual interfaces can be reconfigured at any time to meet your changing needs. AWS Global Accelerator. AWS Global Accelerator is a networking service that improves the availability and performance of the applications that you offer to your global users. Today, if you deliver applications to your global users over the public internet, your users might face inconsistent availability and performance as they traverse through multiple public networks to reach your application. These public networks are often congested and each hop can introduce availability and performance risk. AWS Global Accelerator uses the highly available and congestion-free AWS Global Network to direct internet traffic from your users to your applications on AWS, making your users' experience more consistent. To improve the availability of your application, you must monitor the health of your application endpoints and route traffic only to healthy endpoints. AWS Global Accelerator improves application availability by continuously monitoring the health of your application endpoints and routing traffic to the closest healthy endpoints. AWS Global Accelerator also makes it easier to manage your global applications by providing static addresses that act as a fixed entry point to your application hosted on AWS, which eliminates the complexity of managing specific IP addresses for different AWS regions and availability zones. Aws Global Accelerator is easy to set up, configure and manage. Amazon API Gateway. Amazon API Gateway is a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs at any scale. With a few clicks in the AWS Management Console, you can create an API that acts as a front door for applications to access data, business logic, or functionality from your backend services, such as workloads running on Amazon EC2, code running on Aws Lambda, or any web application. Amazon API Gateway handles all the tasks involved in accepting and processing up to hundreds of thousands of concurrent API calls, including traffic management, authorization and access control, monitoring, and API version management. AWS Transit Gateway. AWS Transit Gateway is a service that enables customers to connect their Amazon Virtual Private Clouds, VPCs, and their on-premises networks to a single gateway. As you grow the number of workloads running on AWS, you need to be able to scale your networks across multiple accounts and Amazon VPCs to keep up with the growth. Today, you can connect pairs of Amazon VPCs using peering. However, managing point-to-point connectivity across many Amazon VPCs, without the ability to centrally manage the connectivity policies, can be operationally costly and cumbersome. For on-premises connectivity, you need to attach your AWS VPN to each individual Amazon VPC. This solution can be time-consuming to build and hard to manage when the number of VPCs grows into the hundreds. With AWS Transit Gateway, you only have to create and manage a single connection from the central gateway into each Amazon VPC, on-premises data center, or remote office across your network. Transit Gateway acts as a hub that controls how traffic is routed among all the connected networks, which act like spokes. This hub and spoke model significantly simplifies management and reduces operational costs because each network only has to connect to the Transit Gateway and not to every other network. Any new VPC is simply connected to the Transit Gateway and is then automatically available to every other network that is connected to the Transit Gateway. This ease of connectivity makes it easy to scale your network as you grow. AWS App Mesh. AWS App Mesh makes it easy to monitor and control microservices running on AWS. App Mesh standardizes how your microservices communicate, giving you end-to-end visibility and helping to ensure high availability for your applications. Modern applications are often composed of multiple microservices that each perform a specific function. This architecture helps to increase the availability and scalability of the application by allowing each component to scale independently based on demand, and automatically degrading functionality when a component fails instead of going offline. Each microservice interacts with all the other microservices through an API. As the number of microservices grows within an application, it becomes increasingly difficult to pinpoint the exact location of errors, reroute traffic after failures, and safely deploy code changes. Previously, this has required you to build monitoring and control logic directly into your code and redeploy your microservices every time there are changes. AWS App Mesh makes it easy to run microservices by providing consistent visibility and network traffic controls for every microservice in an application. App Mesh removes the need to update application code to change how monitoring data is collected or traffic is routed between microservices. App Mesh configures each microservice to export monitoring data and implements consistent communications control logic across your application. This makes it easy to quickly pinpoint the exact location of errors and automatically reroute network traffic when there are failures or when code changes need to be deployed. You can use App Mesh with Amazon ECS and Amazon EKS to better run containerized microservice at scale. App Mesh uses the open source Envoy proxy, making it compatible with a wide range of AWS partner and open source tools for monitoring microservices. AWS Cloud Map. AWS Cloud Map is a cloud resource discovery service. With Cloud Map, you can define custom names for your application resources, and it maintains the updated location of these dynamically changing resources. This increases your application availability because your web service always discovers the most up-to-date locations of its resources. Modern applications are typically composed of multiple services that are accessible over an API and perform a specific function. Each service interacts with a variety of other resources such as databases, queues, object stores, and customer-defined microservices, and they also need to be able to find the location of all the infrastructure resources on which it depends, in order to function. You typically manually manage all these resource names and their locations within the application code. However, manual resource management becomes time-consuming and error-prone as the number of dependent infrastructure resources increases or the number of microservices dynamically scale up and down based on traffic. You can also use third-party service discovery products, but this requires installing and managing additional software and infrastructure. Cloud Map allows you to register any application resources such as databases, queues, microservices, and other cloud resources with custom names. Cloud Map then constantly checks the health of resources to make sure the location is up to date. The application can then query the registry for the location of their sources needed based on the application version and deployment environment. Elastic Load Balancing. Elastic Load Balancing, ELB, automatically distributes incoming application traffic across multiple targets, such as Amazon EC2 instances, containers, and IP addresses. It can handle the varying load of your application traffic in a single availability zone or across multiple availability zones. Elastic Load Balancing offers three types of load balancers that all feature the high availability, automatic scaling, and robust security necessary to make your applications fault tolerant. Application Load Balancer is best suited for load balancing of HTTP and HTTPS traffic and provides advanced request routing targeted at the delivery of modern application architectures, including microservices and containers. Operating at the individual request level, Layer 7, Application Load Balancer routes traffic to targets within Amazon Virtual Private Cloud, Amazon VPC, based on the content of the request. Network Load Balancer is best suited for load balancing of TCP traffic where extreme performance is required. Operating at the connection level, Layer 4, Network Load Balancer routes traffic to targets within Amazon Virtual Private Cloud, Amazon VPC, and is capable of handling millions of requests per second while maintaining ultra-low latencies. Network Load Balancer is also optimized to handle sudden and volatile traffic patterns. Classic Load Balancer provides basic load balancing across multiple Amazon EC2 instances and operates at both the request level and connection level. Classic Load Balancer is intended for applications that were built within the EC2 Classic network. Robotics.